Hello and welcome to Graphing Linear Inequalities. Okay, so what you'll need to know are these sets of rules. Determine if the line is dashed or solid. Okay, so this is a lot like solving those y equals mx plus b's, except instead of that equals between the y and the mx plus b, there's going to be an inequality. And for our purposes, if the inequality symbol is blank or blank, then the graph is dashed. This indicates that the points on the line are not solutions of the inequality. That would be less than and greater than. Notice there's no equal to. If the inequality symbol was blank or blank, then the graph is a solid line. This indicates that the points on the line are solutions of the inequalities. We're going to have less than or equal to and greater than or equal to. Notice the equal to. Graph the line by replacing the inequality symbol with an equal sign. Graph using any method previously discussed. Alrighty, and find our last part. Choose a point on the line as a test point. Substitute this point into the original inequality. If a blank statement is obtained, shade the half that contains the test point. If you get a true statement. If a blank statement is obtained, shade the half that does not contain the test point. If a false statement. Just like as we learned in the previous video, you can get either true or false statements when looking at test coordinate pairs in your inequality. So let's actually get our hands dirty and look at some examples. So example 1, we have this graph, and we're asked to graph the inequality. We have x plus y is less than 5. Okay, the first thing we want to denote is going to be a dashed or solid. And the thing that tells us about that is the sign of the inequality. It does not have that equal to part of it. It's just a regular inequality symbol that we first learned about, so it is going to be dashed. Okay, and now we want to solve the inequality by graphing it. So the first thing to do is to replace the inequality symbol with an equal sign, and then we're going to put it in the y equals mx plus b form by subtracting x on both sides. So we have y equals negative x plus 5. So that tells us the y-intercept, or b, is 0, 5, and our slope is going to be negative 1 over 1. So let's first plot 5, which is right here, and now we'll use our slope. We'll go down 1, go to the right 1. So we go down to 4, and then we go to the right 1. So we're at the point 1, 4. And we can reverse that and go up 1 into the left 1 at negative 1, 6. So now we want to go up and have a dashed line connecting our points, which should look something like that. Okay, and now we actually have to do test points. So we have to test. And this means just to pick a pair of coordinate pairs, either on the the right side of the line or the left side. And whichever one gives you either a false or true statement, that's where we're going to do our shading. So let's choose the points 0, 0. That's going to be this area right here. That's the origin, and it's usually a good point to test. So if we take our inequality of x plus y is less than 5, replace the x and the y with the coordinate pairs of 0 plus 0 greater than 5 to give us 0 is less than 5. Is that a true statement? That is a true statement, and the true statement appears on this side of the graph, so that means we actually want to color everything that appears on this side of the line. That means that this side will yield solutions to the inequality. Okay, if we look at the next example, we want to see if the line will be dashed or solid. And if you noticed here with our inequality symbol, there is an equals, a part of our inequality, so this will actually be solid. Okay, and now I want to put this in the y equals mx plus b form. And to do that, we need to first write our inequality, but replace the inequality with an equal sign. Now let's get rid of the x by subtracting 4x on both sides of the equation. So we're going to be left with 2y is equal to negative 4x plus 8. Let's get rid of everything beside the y by dividing 2 on both sides, leaving us with y equals a negative 4 over 2, so we're just 2x plus 4. That means the slope is a negative 2 over 1, and the b is the coordinate pair 0, 4. So let's start by graphing 0, 4, which is right here, using our slope of going down 2 to the right 1. So go down 2 to the right 1. Or we can use the opposite approach and go up 2 to the left 1. And we have points that we can make a line, and we decided this will be a solid. So now we're going to connect those dots best that we can. Okay, and now what we actually need to do is have a test point. And as long as the graph does not fall on the origin, or this area down here, it's usually the best place to test. Sometimes it will fall, you'll need to choose somewhere else. So let's choose 0, 0, the origin. So let's take our inequality. 4x plus 2y is less than or equal to 8. Let's take our points, our point 0, 0, and replace the x with a 0 and the y with a 0 in the inequality. 4 times 0 is 0, plus 2 times 0, which is 0, is less than or equal to 8. So 0 is less than or equal to 8. And does that make a true statement? That does, because 0 is less than 8. So that means we're going to shade everything that contains the test point on that side of the graph. And finally, we have this example. And the first thing we want to ask ourselves, is this going to be a solid or a dashed line? And I believe you'll see this will be a solid line because of the equal to part of the inequality. So let's put it in the y equals mx plus b form to graph this by first taking your inequality and replacing the inequality symbol with an equals. Now let's get rid of the 3x by subtracting it on both sides. It's going to be left with 5y equals negative 3x plus 15. Now to get that 5 away from the y, we actually want to divide by 5 on both sides of the equation. That's going to leave us with y equals a negative 3 over 5x plus 15 divided by 5, or just 3. So that means our slope is a negative 3 over 5, and our y-intercept is going to be the point 0, 3. So now let's take a look by graphing the y-intercept first, which is 0, 3 right there. Using our slope, we go down 3 and to the right 5. So go down 3 and to the right 5. Okay, now we have 2 points. That's all we need. Let's select a solid line and let's graph these. And it should look something like that. Now something I've forgotten to say is I like to add arrows to the end of my lines to show that the line extends forever in the positive and negative direction. Okay, so now we actually need to find test points. Again, since 0, 0 is not a part of the line itself, let's use it as a test point. So we'll take our original inequality, 3x plus 5y is greater than or equal to 50. Let's take the x and y and replace those with the coordinate pair, placing each with 0, so that's going to give us 3 times 0 is 0, plus 5 times 0 is 0. It's greater than or equal to 15, or 0 is greater than or equal to 15. Is that a true statement? Well, that is not. So that means that we will not shade in the area of the test point, because that is false. So this was our test point. We're going to have to shade in the opposite direction. And just for consistency's sake, I'm going to go through, and on these previous problems, I'm going to draw arrows to show that the problem, or the line itself, continues on forever in positive and negative infinity.